this morning. This is the first time. I did do it with the mouse. The mouse works. So I know it works, and it worked before. That's not the problem. Problem is, yeah, it's not covering up the whole screen, so I doubt it's going to work. But anyway, we'll try it. Here's one of the questions that was sent to me last week, and we kind of abruptly went over it. And I think this is the one holding up everybody. I got 3 questions that I think are holding up everybody. And that's why I decided to go over it. And hopefully everybody will feel better, because there's still about 5 or 6 of y'all that haven't done the homework, and I don't know what you're waiting on. And there's about, I would say probably 10 of y'all that haven't taken the test. And I understand that, because you're waiting until tomorrow or Wednesday to take the test. I understand that. But I don't know why you would wait till Wednesday when you could take it today or tomorrow. But anyway, I'm not one of those people that procrastinate. So in a game of roulette, when a player gives, first of all, this is not a test question. There is a roulette question that I give you, but it is more of the probability and the odds against. I don't do this. Where'd you go, Miss Yoder? Something wrong? I don't give this question because it's too busy. What do I mean by too busy? It screws with your head before you even start on it. Okay, so I don't give this question on the test. But let me go ahead and find this question, because I wrote everything out. Let's see if this is it. Yep, this is it. Okay. So the first thing you're going to do is do the expected value. Yeah, it's not working. I still have to write to the right and the left. So A, hold on a minute, let me see if I can get the eraser to work. If you're wondering what's wrong, my pen is actually about 3 to 4 inches to the left of where I just wrote that A down. So I'm having to write 2 or 3 inches to the left. Expected value. Expected value of betting on number 11. Okay? So here is the expected value of betting on number 11. And you're going to follow the same procedure. And it's real simple, but the way that they write the question and the way that they explain the question is kind of like going around the world instead of around the bush. I mean, it's just going around the world, and it's just not needed. So, losing and winning. And losing is going to be negative $5 times 37, let's see, probability of losing $5 and, okay, 37 over 38. And that comes out to be, y'all can check your calculator, negative 4.87. And the probability of winning is going to be $175, or not the probability of winning, the expected value of winning times 1 over 38, which is equal to negative or positive 4.61. Add those two together and you get negative 0.26. So that means that you're probably going to lose. The expected outcome for that bet is you're probably going to lose. So that's what you're finding, the expected value. So like I say, I don't test very much on the expected value. I mostly test on probability. I'm trying to make this smaller. It's kind of hard to do when you can't put your, there we go. All right, now I want you to do B the same way. So I want you to forget this. Let's see. Forget all this. Because I just did that part. Now I want you to do B. Same way I did. Same way I did A. Instead of betting $5, I mean, you bet $5 and $5, you win $5 instead of 175. All right, so here, B, the only thing you got to do is instead of 175, you're going to substitute a $5, and then you're going to substitute the probabilities. So for B, the expected value of an odd number. So you got a -5 that you lose and a +5 that you win. And the probability of winning, of losing with the -5 is 20/38. Multiply that together and I get -2.63. Multiply the +5, which is what you win, times 18/38. And that's equal to 461. Add those two together. Wait a minute. No, 237, sorry.
I was about to check my work. I thought I did it wrong.
No, I was copying the wrong notes. The reason I did notes is because I'm not in my house, and I have to do things different here because I know the technology is not going to work. So 2.37. And that equals -0.26. So you're going to lose the same on both. And that's what you conclude. You get -2.6. Somebody check my math. Do you get -0.26 on both?
Yes.
And that's the whole point of these gambling questions. Why do you gamble? Somebody tell me why people gamble. There's several reasons people gamble. Tell me why you gamble.
To gain more money.
To gain more money. So would you say that some people do it for income?
Yeah, it's possible.
Those are professional gamblers. Those are the people that live in Las Vegas. And they wake up at 10 o'clock in the morning or 12 o'clock in the morning, and they go to the casinos at 5, 6 o'clock in the afternoon, and they stay until 2 or 3 o'clock in the morning. And they gamble, and they lose money, and they win money. And I don't know about that lifestyle. I don't know if I want it, because I'm the type person, if I touch a piece of gold, it's going to turn to 10. Okay? So I don't have that Midas touch that some people have. Not many people do. What would another reason people gamble? Why do you go to Las Vegas? Do you do it for income or do you do it for fun?
They have an addiction.
No, well, that's true. That's an addiction, yeah. And I think that would be people that has above income. They think they can win their way out of debt. Now, what would be the third reason? I was trying to lead you that way, but I'm glad you said addiction, because that's true. What's the other way? Just for the what?
The money?
No, just for the blank of it.
Oh, for fun.
Some people just do it for fun. Who is that? Well, when I was first at Tri-County Tech, they told me that I needed to go to Denver and go to a conference out there. And they sent me out there, and I took at that time, I took my wife. And she went crazy over the slot machines. And I'll never forget that. I never noticed that in her 2 or 3 years of dating. She was just having a ball with those slot machines. She was having fun, okay? She didn't win very much. She won like 25 or 50 bucks off of the total, but she was having fun. Now, does she go out there every 2 or 3 months? What happened to my videos? What's up? Justice and Miss, where'd you go? That hurts, man. That really hurts. Anyway, what?
I don't know. I was just
That's all right. I'm just picking at you.
I was the only one with the camera on.
Well, I know. See, how does it feel to be the only one with the camera on, Justin?
Must feel pretty special.
It makes you feel.
Feels like I have all the eyes on me.
So Miss Holder, I should feel special. Is that it?
I don't know. I'm trying to start a trend. Maybe other people will engage too.
Oh, listen, you can forget that. You can forget that. This class is the hard rock of. Oh my gosh!
Wow!
Oh my! Look at there. Miss Holder, you did something. Oh, thank you, Miss Holder. Miss Holder and Mr. Justin, thank you very much. Mr. Adams did come on last time. I remember Mr. Adams come on last time. So thank you. I'm trying to push Miss Gill to kind of send but she won't bite. I've tried several times, but she won't bite. But anyway, some people do it for fun. And those are the people that go out and buy a lottery ticket, like me. I go out and I buy a lottery ticket maybe once or twice a week. $5, $10. Is that addicted? No. Is that trying to be my income? No, because I come to work every day. So, nothing is wrong with gambling. People do it every day. People get in a car, don't they? You drive down Interstate 85, don't you? That's a gamble every day. Y'all ever seen the movie Benjamin Buttons? Anybody ever seen that movie? Oh, forget it. It's not a Marvel comic or a cartoon.
Yes. And I think it's Benjamin Button. I don't think.
I'm sorry, what?
Buttons.
Isn't that the one where like
He ages backwards.
young?
Yeah.
Like he's young.
And the guy in the nursing home gets hit by lightning 7 times. That is the funniest scene is where he gets hit and he keeps coming back in the movie. I got hit when I was checking my cows, and it shows him getting hit by lightning. It's hilarious. But anyway, to make a long story short, you gamble every time you go outside. All right. So to say gambling is awful, well, think about when you go outside, you can get hit by lightning. All right, next thing. Next. Oh, I'm sorry. Hold on. There we go. Find the probability of being dealt 5 cards from a standard 52 card deck and getting a full house, 3 of a kind, and 1 pair. Now, this question can be done in 2 steps, but I looked at the explanation on this thing and I'm like, no wonder people are sending me this question because they don't know what to do. The first thing you got to do is find the denominator. So write that down. The first thing you got to do is find the denominator. I was confused when I read the question the first time. I thought it was a combination. Multiplication problem. Find the denominator. The denominator is going to be this number is equal to R, and this number is equal to N. So 52 combination of 5. The denominator is how many 5-card hands are in a deck of cards. Now that doesn't mean 3 of a kind. That means a royal flush, a flush, nothing, 2, 3, 4, 5, 6, which is a straight, 2 of a kind, 3 of a kind. How many different hands are in a deck of cards? So somebody punch that through your calculator. I'm not going to try to pull up the calculator. Heck, I can barely get the whiteboard to work right. When I punch it in, I get 2,598,960. That's your denominator. Write that down. That's your denominator. Now, some of you poker players out there, tell me what a full house is. My gosh, really? I got people that's 18 years old and you don't know what a full house is? Nobody in this classroom knows what a full house is. You have got to be kidding. It is 3 cards of the same suit and 2 cards of the same suit.
Also, how did you get the 2 million?
Well, check it in your calculator. It should be 52 combination 5 in your calculator.
Okay.
Did you check it? I showed y'all how to find the combination the first day that y'all didn't communicate with me when we started this. Half of y'all didn't write it down probably, did you?
Did I miss that class for work? Because I don't even remember.
That's the day you missed, Miss Gill. That's when nobody would communicate with me that day.
I'm sorry. I have to catch up on watching the videos. So I haven't.
Yeah, that's fine. That's okay. That's when nobody would communicate with me, so I just went through 3 sections in about 30, 45 minutes. Let me show you, because I showed y'all, that's the day y'all, I don't know if y'all were hung over or what. I don't know what y'all were, but y'all wouldn't talk to me, so I just kept on going. I think that was the first day Mr. Adams actually turned his video on, wasn't it, Mr. Adams? All right, so here we go. We're going through this again for those people that didn't pay attention that day. 52, math, probability. Is it coming back now? Nobody gonna say anything.
Number.
There you go.
Math. Probability.
And then 5.
Do we click number 1?
I'm sorry, what?
Did you
52,
click
here we go. 52,
Uh-huh.
math, probability. Oops, sorry, hold on. I hit the wrong button. NCR, that's a combination.
NCR. Okay.
And then 5. Combination means no order. Remember I told you that. Combination means no order. I didn't say what the order was in the, oh my Lord, Miss Blue, how are you doing?
Good. How are you?
I'm just so happy. I could see 4 people. You know, I could see up to like 9 or 10 people at one time. I'm just letting y'all know that. Okay. Beggars can't be choosers. I'm gonna be happy
4
with
isn't
4.
enough for you?
What?
4 isn't enough for you?
No, well, you know, I'm gonna be okay, miss. I'm okay. I'm okay. Fine.
It's a better turnout than last time.
Oh, me. Miss Holder, you look like a fashion person. Are you a fashion person?
I'm in my closet, if that's what
Oh, is that why?
Yeah, it was quiet.
You know, there's 3 people in different classes that are in their closet. I got one person that's in their laundry room. I don't know why they're in their laundry room. I don't ask. But anyway, evidently they have a wild, crazy house and they just go into the laundry room and that's where they do their schooling. Okay. All right. But yes, when you hit math, let me do permutation. Permutation is with order. That will be 52. Permutation, which would be probability, and permutation, which is number 2. And that is 5. Now it's going to be a bigger number because there's a whole lot more straights. There's straight would be 2, 3, 4, 5, 6, and then 3, 4, 5, 6, 7, and then 5, 6, 7, 8, 9, and then so forth. So you got to count every one of those because they're in order. So that's why combination is no order. Combination is no order. Permutation is order. I know I told y'all that. Okay? Now, let's go back to the question. So the denominator is that. Now, somebody tell me, I asked y'all a question now. Y'all got to tell me, what is a full house?
It's a 3 of a kind, and then 2, it's a pair.
Okay, so it's like, I lost my notes. It's, let's see if I can do this. Like 3 hearts. This is going to be hard since my pen is not where the cursor is. Three hearts and 2 diamonds. Hold on. Laura, let's go with 2 spades because they're an upside down heart. Oh, shoot, I messed that one up. It's hard for me to draw a period, and then it's especially hard when my pen has to be 3 or 4 inches to the left of where I'm drawing. Okay, so that is a full house right there. A full house is based on the suit. Okay, so let's write that down. A full house is based on the suit. Full house is based on the suit. So I could have 3 spades and 2 diamonds. I could have 2 kings and 3 queens. I could have 2 aces and 3 fours. Okay? They're based on the suit. They got to be the same suit. Does everybody understand that? Okay. So, how do we set up our numerator? Our numerator is based on this guy, what I just drew you. Sorry about this. Can't write. All right, numerator is based on what I just showed you. How many how many cards are in each suit? Somebody tell me that. There's 4 suits. How many cards are in each suit?
$13.
13. So I got to have at least 1 suit to match, like hearts. And out of that 1 suit, how many cards do I have to have of hearts?
Three.
Thank you for counting the 3 hearts that I have on the screen. Thank you. All right. So I got 13 suits, and 1 suit, I'm going to put right below this one. I need hearts. I need all 13 cards to be hearts. Now, how many cards of hearts do I need? I need 3. And how many suits are there? How many suits are there in a deck of cards?
4.
Right.
Okay, so out of the 4 suits, I need how many?
3.
3. All right, that's one part. That's for this right here. Now we got to do for the other. Now, my question is this. Once I've got 1 suit out, once I've got 1 set of cards out, how many cards are left? So I've got one card out of each group. You said there's 4 suits, right? I'm sorry, 13 cards in each suit. And I take 1 card out of each suit. How many are left in that suit?
12.
If I take 13 cards and I subtract 1 out of 13, how many have I got left?
12.
So now, in each suit, I have 12 cards, and I'm going to pick, I need to get 1 suit, and that's spades. And out of that suit, I've already got 1 suit over here, okay? How many suits do I still got 4 suits to choose from, but how many do I need now? How many cards do I need with that suit? 2. And that right there is that one, and that's your numerator. And when you do all of that, and we'll do it in the calculator, that's going to equal 3744. So there's 3,744 full houses in a deck of cards. Now, the best way to understand this question is to get you a deck of cards and do it. Divide the deck of cards. I'll show you what I'm talking about. Because some of y'all have no idea what I'm talking about. Whose fault is that? It's your parents. It's your parents' fault. It's a joke. Don't cancel me out. I'm just kidding. Develop a sense of humor, please. All you got to look here. I'm going to show you a trick I learned in the war. Deck of cards and hit. Look at there. Oh my gosh. Would you look at that? Would you look at that? Yeah. Would you look at that? Some of y'all know what I'm talking about. There it is right there. I tell you what, let's save it. Save image as deck of cards. Since I have to educate some of y'all, let me go ahead and educate some of y'all. Pull up the whiteboard. And let's add another. And let's insert. I want to blow it up, is why I'm inserting it. See, I can use technology. The problem is I can't use brick phones. There you go. Now let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 cards in each suit. 13 cards in each suit. And how many suits are there? 1, 2, 3, 4. And that's where those numbers come from. So what I would do if I was you, I'd print this out on a sheet of paper and maybe look at it while you're trying to figure out how to do that last problem. And I guarantee you, none of y'all thought about, did any of y'all get out a deck of cards while you were trying to do this problem? No. Just thought that answer was just going to hit you in the face. Divine intervention, right? Yep. Just like Superman and Batman and all those, and Little Mermaid. Don't forget about her. Just going to hit you in the face. All right. So let me get back to my question. There we go. So I'm going to do this in my calculator. Let me pull up my handy dandy calculator. And I'm going to have to do this. Just give me a second. I've got to maneuver things around. Bear with me a second. This is so much easier at home. But I got to use the brick phone. All right, so here we go. Parentheses. Well, I'm going to show you how to do it without doing a bunch of parentheses. Anything 13 combination 1 is going to be 13. 12 combination 1 is going to be 12. Remember that. Because 13 times 1 is 13 and 12 times 1 is 12. But I'm going to show it to you. 13, math, probability, 1. Enter. And watch this. Here's a trick I learned in the war. If you hit second, enter, it brings back the last thing that you punched in. So now you can put a 12 in there. Look at there. I bet y'all didn't know that. Hit it again, second, enter, change it to 4 and 3. Now to save spaces, I'm going to put 4 and 3. I just did that so I would save those spaces. And then the last one is what? 4 and 2. So it looks like, let's see what we got. 13 times 4. 13 times 4. And what? 12 times what? 6? And that's going to be 52 times 72. It's a miracle. And now we take 3744 and divide it by what? The denominator, Hubert. That's right, class. Thanks for the interaction. 2,598,960. And there is the probability of drawing a full house in a poker game. You've just about got the same chances as winning the lottery. So, Miss Holder, you need to watch your gambling addiction. Question on that question. So your denominator is going to be 52 combination of 5. If it asks for a full house, then it's going to be 13 combination 1, 4 combination of 3, times, you're going to bring 1 down. At 13, you're using up 1 set of cards, so that leaves, or 1 card, that leaves 12. And then 4, 3, this is going to match how many you need here, and this is going to match how many you need here. And that's how you do that question.
Doesn't one have more of a chance to win at gambling than they do at the lottery? Because you can like count cards.
That's blackjack.
Oh. Okay.
Blackjack is, you can count cards in blackjack, just like you can count cards in spades. How many of you have ever played spades before? Anybody? Okay, Mr. Adams, you know when people talk junk, right? When you play in spades and you throw down the first hand, everybody knows who's got what. You've already counted the cards in your head. That's how people, when they play spades, they throw down 1 or 2 hands. They already know what everybody's got because they're counting cards. They've counted how many spades they've got in their hand. Their partner has bid 2 or 3. They bid 6. 2 or 3 plus 6 is what? 9. So you know that the 2 partners to the side, they have like 4. And when they throw down their highest card, you know that they don't have many spades because they're throwing out their highest card. Mr. Adams, you know what I'm talking about? When you play spades, spades is another form of counting cards. Now, it's hard to do with poker because there's so many different hands. So when you're trying to blind me with that flashlight, Mr. Adams, that's what you're trying to do. He's trying to shoot me with a laser, y'all. All right, so here's the next question. But yes, that's a good question, Miss Holder. There's a lot of movies based on counting cards, and blackjack is the one that you count cards in. I wish I could do that. I wouldn't be here teaching. I'd be in Vegas. Oh, also, that's not a good test question. I usually hang with the lottery questions on test questions. All right, here's this one. Go ahead and write that one down. Is it a test question? No. But some of y'all sent it 2 or 3 times in your homework. So that's why I pulled the 3 top questions that y'all sent, and all of them were the same. Y'all sent these 3 questions. So that's why I'm doing them. I didn't get any other homework questions from anybody. And I doubt very seriously that the 5 or 6 that Haven't done any, except for, I know Miss Gill, she hadn't had a computer, so that's why she hadn't done hers. But other than Miss Gill, I don't know anybody that's called me or told me that why they haven't done the homework. It makes no sense. Now, this question is not very difficult, but it is a busy question. It is a question that people get confused with. The first thing you do for A it says, suppose you play a coin toss game in which you win $1 if heads appears, and you lose $1 if tails appear. So you basically, the dollar amount is $1. I mean, you're talking about winning $1 and losing $1. And you're going to do the expected outcome here, and you're going to add it to the expected outcome here. So what is the probability of winning? How many times did it show up heads? 30 over 100, Hubert. That's right. So that would be what? 0.3. And then how many times did you lose? 0.7. And when you do that math, you come out with negative 0.4 or 40. Okay, 40 flips, negative 40. So that means you're losing no matter what. The quotation losing means that you're not going to win very much no matter how many times you flip the coin. Because out of 100 times, you either got a coin that likes to flip to the tails, or you've got a loaded coin, one of the two. Gravity, the way the Earth's spinning, something. B says, what happens, what is the expected value if you flip it 200 more times? Which now n is equal to 300. So the only thing you got to do now is you got to do 1, that's the dollar that you win, multiplied by, well, let's see, if you, and it says it has a 0.35 probability, I think, yeah, the probability of heads is 0.35, therefore, the probability of tails is equal to 0.65. All that's given. So the probability of heads is going to be 0.35 times 300. Plus, you lose $1 with 0.65 times 300. So crank that out, and you get negative 90 or negative 0.9. Negative 90 is good enough. So you're still losing. You're losing with 100, and now you're losing with 300. So it looks like to me, you're not gonna be winning anytime soon. Unless you change coins. Because you still got a negative number. You get a positive number, that means you're winning. And that's why these are called expected values. Hold on a minute, I'm gonna try to. Oh, me, really? This is so frustrating. Y'all don't know how frustrating this is. Whatever, I'm not gonna worry about it. We're just gonna have to meet, I'm just gonna have to meet here and we're just gonna have to make it through this, so just on Mondays and Tuesdays, well, Mondays for y'all. C says, toss it another 100 times, another 100, and now you're at n is equal to 400. And they want to know how many more flips are you going to do to break even? Well, breaking even is 200. I'm going to put break even equals 200. Well, you've already got 135. You got 30 times the first one. Wait a minute. 105. Yeah. At 300, you got 105. At 300, you have 105 flips that are heads. Okay, at 300, you have 105 that are flips. And you get that from this right here, that are heads. So 200 minus 105 is equal to 95. And I doubt very seriously that you're going to get another 100 flips. You're going to get 95 of them. Now, they ask you D, they ask you about, and we talked about this in the last class, they ask you about what's the gambler's fallacy? That after 400 flips, I'm losing. I'm still losing. So that means I'm due, and the word is due. I'm due some good luck. And what did I tell you about the word due with gambling? We only talked about it like 2 or 3 days ago, which was Friday.
Nobody's
And this
due
thing
anything.
writes half the time and it doesn't write half the time. So what'd you say?
Nobody's due anything.
Nobody is due a damn thing. Nothing is free. Nothing is due. You ever see these movies where, what does Rocky tell Paulie? Nobody owes you anything. Nobody, you're not due anything. And especially when you're gambling, you're never going to win unless you're at the right place at the right time. And that's what luck is. How many times have you seen a movie where somebody won $1 million? They were at the right place at the right time. That's what luck is. Luck is not obtained. Luck is not measured. Luck is not due. There is no such thing as luck being due. Capiche? Okay, y'all settle down.
Capiche.
There you go. Thank you, one person. I appreciate it. Thank you. It's always nice to have one person acknowledge that you're alive. Thank you. All right. Did we get any more people coming in? Nope. Nobody else came in. It's 10:06. We're already over. So I'm going to cut off the recording. We'll review the test Wednesday. Y'all better send in questions. Y'all have a good day.
Have a good day.
Bye-bye.
You too. Thank
Thank
you.
you. You too.
You're welcome.